Well, let's run a baseline comparison. Now you recognize this. This is just your typical mason jar. Got some little fingerprints on it, but let's see what it'll do with city water at about 50, 60 psi. It varies through the day and whatnot, but let's see how long it takes to fill this up. Now, pretty close to the top of the rim. I don't know if we can see that, but it's pretty close to the top of the rim. We'll pour that out. I'll use the software to figure out how many seconds that was. Just slide this out of the way. Now, this is our RO system, our whole house RO. Now, when I call it a whole house RO, we're not flushing toilets with it. We're not mopping floors. We're not watering lawn, that kind of thing. But there is at every bathroom lavatory, the kitchen sink, and the ice maker all have a faucet, a RO system. Let's see what we can do out of our homemade system. You ready? Make sure I don't cheat. How about that? Now that's not scientific, but now we're filled up at least as far as we did the other one, and I'll do the timing. So we've got some pretty reasonable delivery on this system. So if you want to see how we did this, come on back. Well, hello. Hopefully that opening worked as a tease to get you to want to watch more of this particular show. Anyway, I'm Dale Delbridge. I'm here to run this little show and to show you how I put in a whole house RO system. As I've already told you in the opening, the whole house is we're not showering with it, flushing toilets with it, but for our potable water needs, it's cleaned up, it's been de-rocked, and it is sanitary, and we're good to go. Now, at this time, we are actually on city water, but this thing dates back 16 years when we built the house and we were on a well. There are some options I talk about for people who may have that kind of thing, may still be on that. I think it'll be good for you to watch. For someone who just wants to have a nice system, I think that'll be good. I don't have it under counter, so I don't have to fuss about somebody where you used all your space up with that dad blasted system, blah, blah, blah. And I don't have one, I don't have 4 of them, 5 of them, whatever, throughout the house. It's a central system. I think it works well. You've seen it. The delivery, I like it. Works good. Has been for 16 years, although I just recently addressed some of the issues that came about by my learning curve as I was doing it. So if you'll watch the video, I think you'll cut your learning curve down substantially. So come on back, get you a cup of coffee, sandwich, candy bar, whatever you might need, a little shot of something else stronger if you're going to have to sit through and watch me. And it's going to be a long show, but I think it'll be worth it. I think it'll help you understand what you can do. There's just so many things that are in this. So subscribe, for goodness sake, subscribe and watch these videos for me. It'd help me out a lot. I'm not monetized, going on like 4 months of not being monetized since I applied in that last stage. I don't know anybody's going to sell or buy my ad time, but if they do, that's the only cost you'll have, is to sit through a little bit of a commercial here and there. And I hope the knowledge is worth it. The information it gives you is worth sitting through a commercial or two to do it. And do support those sponsors if they actually have any. So appreciate you. Let's get to it. Well, let's talk about components. What are the minimum number of components you can have to have an RO system? Well, one, the membrane, the RO membrane. It works like you might think of a standard air filter in your house or a water filter. It in effect has a device that will not allow the stuff, the salts, the dissolved solids to pass through, but will let smaller stuff like gas molecules, like hydrogen sulfide gas molecules that you have in sulfur water and other things like that will pass through. Water will pass through, and it separates and comes in the feed, and it splits. The red is the brine or the reject water, and the blue is the good water, the house water, the RO water, whatever you want to call it. So the minimum you need is this. However, in your components, you'll almost find on every little rack system or manifold system, you're going to find a couple of little cans. So what's the next one? Well, chances are you're going to have a pre-filter. Now the pre-filter does a couple different things, and what type of pre-filter you need depends on your water conditions. If you have a well that's a little bit muddy, a little bit brackish, a little bit cloudy, you might want to even have two pre-filters. One that takes out the large sediment that will clog up fairly quickly, and you'll maybe change that out more often than you would the next stage filter or the finer stage filter, which would be another particulate filter. When I set the initial RO system up, I used only a white filter, a particulate filter. And that's because I was on a well. It was in fact chlorinated, but it had already been processed in the facility. I have actually two little facilities, chemically treated, mechanically treated, chemically treated, and it actually goes through a chlorinization process, and then the very last stage is a big tall computerized filter about yay big with a backwash computerized time head on it, and it took the chlorine out. So inside I just used a white filter to take out the particulates. If you live in the city, you're going to have at least some carbon in your first stage filter, because without the carbon in here you can't take the chlorine out, and chlorine will wipe that membrane out. So you'll have at least one filter, whether it be for chlorinated water or for filtering your material out. This one does both, no more than I have of either. City water, clean water, fairly good. Got that. Okay, now you'll have probably at least a post filter. And the post filter just sort of there for buffering and running it back through the carbon, kind of takes some of the edge off of this demineralized aggressive water. That's what that does. Now you might see on some other rack units or manifold systems, you might see a number of things. I talked about chlorine. All right, David, are you listening? All right, David, because see, not everybody chlorinates their water. They may use spring water or well water, they may not chlorinate. So they do make RO systems that one of the options, there'll be an additional filter-like device on there, which is a UV filter or a UV sanitation tube where the UV light kills whatever's coming through there. Not a bad idea, David, if you don't want to go to all the trouble of maintaining and dealing with chlorine and getting the proper balance, so you don't have too much chlorine or too little chlorine, not enough residual, too much, that kind of stuff. A UV light on your RO system to drink water with or to make ice with is probably not a bad idea. And again, one or two filters, pre-filters, you may have an UV light, you may have a post or buffering type of filter. You also might have a remineralization filter type device. It's basically not really a filter, it's just a tube with different types of materials in there that we run that aggressive RO water over, so that it picks up some minerals you get back out of it. So you took them all out in the front. Now your idea is you'll put back only a known type of chemical back in it. And you don't want to drink RO water exclusively. It's got health hazards of its own. Now if you have a lot of rock, a lot of dissolved solid, a lot of calcium like we do in Tennessee, limestone, Tennessee, you can get things like kidney stones. There is a benefit to drinking RO water, but you don't want to drink it exclusively. And if you are going to drink it exclusively, then you might want to look at one of those remineralization processes. Now let's talk about piping. Now let's talk about how this thing is actually piped or water passes through it. Well, down here on this side that's the inlet. So the water comes in. This is house water, potable water. It comes in, runs through this tube, runs up and into the dechlorinization filter, dechlor. Take that chlorine out so we don't wipe out our membrane. Comes out of it into just a clear piece of tubing, comes into this pump. I call this the high pressure pump because it boosts the pressure. Boosts it up to 90 psi. That's where I have it set. It comes out of this into the green circuit, which is the high pressure circuit, comes out of it, goes through here, goes over the top, comes out of the back to a little T right up here in this corner. Comes out of that T and comes down into the membrane. The other side of the T comes down, comes through here, into this line and comes down to the small tank or the high pressure tank. Another line comes off here at the top where this valve is, goes over the top, comes down the bottom, runs down this side, loops up, and feeds this pressure gauge. This pressure gauge is not what the house sees, it's what the RO system sees. And it is between. Part of the benefit of doing this versus taking a manifold system is I put the pump after the pre-filter, and that's not necessarily to save this pump. I put it afterwards so that I'm not jacking this particular pump up to 100 psi, because that can make changing the filter a little bit messy, although it does have a little burp valve over on the side. It's still, I'm saving that extra pressure, help my gaskets last long, or O-rings in this thing last a little bit longer. It's just a way to do it. Pre-filter, then pump. Out of the pump into that high pressure circuit. That's all of that high pressure circuit. The next circuit, or two actually, has a blue color traditionally and a red color. Now the red color is brine. That's your wastewater coming off of that membrane. So it comes up, goes through a flow restrictor. You can see the little white heavy thing right there. That's a flow restrictor. I will talk about what it does in the functioning section, or when we get to performance. Comes out of it into this pump, which we'll talk about that when we get into the performance section of this. Comes out of that pump, comes down to a drain and waste down below. Now the blue circuit, or the permeate, or the RO water, or the good water, or the product water, whatever you want to call it, I don't care. But it's going to come out of this. This is our output. It comes out of the blue, comes up, comes behind this filter. That filter comes up into this device, which we're going to talk about that when we get to performance. Comes out of this guy into another line that hits a T. Now, one line goes up, around, and comes up here and hits this pressure switch that you see right there. We'll talk about that when we get to the performance section of this film. All right, the other side comes down, runs around to a change in size. I go from a quarter tubing to a 3/8 tubing. The house is plumbed in half, and that's plenty enough. The issue is 1/2-inch poly tubing doesn't bend well, and it doesn't play well with others, and so it tends to want to leak. So I did step it up to 3/8 for this next part of the circuit, just to help keep the pressure loss down, keep delivery nice and favorable for us, so that we like it when we get it. So it comes out, it changes size, that little blue piece here hits a T. One side goes up, 3/8 now, into the post filter, still at 3/8, comes out, runs through the short yellow, the little yellow, which is now house feed, comes down through here and up to this second pipe, which is actually plumbed through the house to 3 lavatories, a kitchen sink, and an ice maker. It runs it all. This system runs it all. The other side of that comes down, runs behind the membrane, comes out, is in this one, this blue circuit here, this 3/8 blue line, and goes down to our low pressure tank. And we'll talk about that when we get to performance section. Now, you ready to talk about performance? Okay, let's do that. Now, inside of this membrane housing is, I think, either a 50 or a 75. It's not 100, but it's a 75 gallons per day membrane. The first thing you need to understand is 75, 50, 75, 150, 300, whatever yet, does not actually mean 50, 75, 100. I know what you mean. I know what you're thinking. It says it's 75. This manifold system is advertised to do 75 gallons. That's the rating of the membrane. And it was explained to me early on when I was researching this, as I was building this house. I discovered that a 50 gallon per day membrane is rated that way. I'll talk to film tech people. Maybe something has changed. Don't take this as word of God. This is just a bodgy old guy on the internet telling you. But at 50 gallons per day, it won't produce 50 gallons a day. That 50 gallons a day is based upon 100 psi differential between the green side and the blue and red side. And that's very difficult to do if you have a well running 20 to 40 or 30 to 50. So if you're not maintaining 100 psi difference across that membrane, it's not going to produce it. And I run 90 when the pump runs, but the pump doesn't run all the time. So that was the first thing that we will have to kind of think about. We have two choices, one or the other, the permeate pump or the actual pressure pump. Pressure pump increases output by increasing pressure. Genius, isn't it? We're putting more pressure on it, so it's got a harder squeeze to push it through this membrane. We also had another problem when we fire up, which this takes care of. This is our delivery pressure pump. It actually runs off of the wastewater or the brine that comes out of the membrane. Comes up and it's a mechanical pump, comes up here and runs this little diaphragm in here with this little piston, little diaphragm. And the physics of it is it runs out the wastewater, pushes this, which pumps the blue circuit. So it jacks up our output. And in my system, I have the tank pressure set at 50 psi. It runs at 50. The tank itself is not charged with 50. I think it's charged with 40 or 45. But it actually has 50 psi on the line that runs through the house. Okay? And when this runs, I have 90 psi. It wasn't 100, but I backed it down because I got tired of replacing this particular gauge because the wiggle in that tends to cause problems. Now, to cut down on the wiggle, inside here where the green is a blue insert or orifice, which would normally go in the restrictor down here at the brine. But I have a flow device over here to take care of that, so I had an extra. I put it in here, and I also have a brass screw that I drilled a small hole through to kind of give it a little bit of a physical dampening effect to this gauge, because gauges are about 10 bucks a piece and I'm tired of buying them. So that's what that's for. Now, the pump takes the wastewater and raises my delivery pressure. That's one of the problems that we have with RO systems with the under sink models. Baby, they better be real close to that faucet on top of that sink, to that tank underneath, because there's very little pressure. Again, I said if I had a 30 to 50 setup or a 20 to 40 setup with a well system, that wasn't much pressure, and I can't get it all in there. I can't use all of it. In fact, we have this thing called a tank cutoff or a tank switch or an automatic shutoff or 100 other different things you might want to call it. But what it's designed to do is it's designed to sense the pressure on the tank, and when you get about 3/4 of the pressure on the tank that you have on the line feeding it, it'll cut the water off so that you don't run all day. Because this alone, the membrane alone, will pee a stream of water through the red line, the waste line, 24/7, 365, and you're going to get you a water bill off of that. So we use a tank shutoff to fix that, to address that. The thing is, when I use this permeate pump, I get the benefit of elevating my delivery pressure and cutting the waste off when it gets happy. As it pumps up, this quits cycling or slows down on the cycling, and it cuts the brine off so it sits there and you're not wasting water. Now, this pump, again, is to create a greater pressure differential on it. And if I'm running 50 down here on the tank for the house, I need some pressure on this membrane. So even now when I run it, I've still only got 50 psi, not 100 psi across that membrane. So if I have 100 gallon per day membrane in there, I can expect at best, if it's linear, 50 gallons out of it. And if I have a 50 gallon membrane down here and I'm running 50 up here and 50 down here, 100 up here and 50 down here, I'm only going to produce it at maybe 25 gallons or so. Now, this pressure switch is connected to the blue line, which is the house side, the low pressure tank side. When this tank drops down 20 psi, it's actually less than that with that particular switch, but I have it set mostly to kick off at 50. So whenever it drops that pressure down, before it gets completely empty, the pressure drops, it sees it, it kicks this pump on. Now this pump is not a bypass pump. It is actually a straight up diaphragm pump, and it has a pressure switch built in. That's what I have set to 90 psi. Was 100, now it's 90, and it runs. And the purpose of that little tank down there is to allow this type of pump to come on. When this switch closes, it stays closed until we get up to 50 psi, and the pump cycles off of its pressure switch, and it runs down through that green line to that small tank, and it'll run a gallon or so in there, and it'll bleed it off through the membrane, and then it will charge it back up, charge that tank back up, and cut off, so that this pump is cutting in and out rather than running dead-headed while it tries to build that pressure back up on if you have a bypass head. Some pumps are bypass head. They have little valves open it, so when it pumps against something it can't push against, it comes up, runs around the top of that pump, comes right back in the inlet, and that can cause some heating. It also would make a lot of noise and run a lot longer. Now, this big tank I have below me is a Wellmate 6. Wellmate 6, if I have 30 to 50, if I run it in the 30 to 50 psi range, which I do, I get 6 gallons of drawdown. That means when I'm charged up in this tank, I have 6 gallons before it drops down enough to kick that pump on. It's capacity. So I'm able to first recharge faster, and I'm also able to store more, so I can run all of my fixtures and appliances and not run short of water. Well, now let's talk about how this particular thing is constructed. This is the recently rebuilt section. It was working before, but it was suspect to leak from time to time. Anything that has wheels or water on it is going to give you trouble. You can just count on that. Wheels or water, gonna give you trouble. And this is on the second floor. Now, why did I have it on the second floor? I know we're talking about construction, but when I designed the house, because this is about 10 foot up plus this height, but then I have the counter height to make up for it. Let's just throw that away. You have what we call feet of head. With 10 feet of head, I get, and with the floor system is a foot in height. So let's just say we get about 5 psi with this tank, this and this tank being on the second floor. So I automatically get a natural gravity-based boost on our performance. See the previous section with this. Now there's only one tap off RO, which is the lavatory across the hall in the upstairs bathroom. So all the rest of the appliances down, I get a bonus 5 psi, give or take, off of it, just because this is on the second floor. The downside of it being on the second floor is if we spring a leak, there's a good chance it's coming through the ceiling and we got to do some repair. Even if it's just temporary, just not rotting damage, just enough to make sheetrock crack up. That's a problem. So that is, you give or take. Some people will put a system under the house and have to crawl under it. I'm not a big fan of that, because I tend to be lazy and not get my filters changed on time, and I certainly don't want to have to be where an old man like me, a chunky old man like me, has to crawl under a house to do a filter. Also, out of sight, out of mind. It's just not a good idea. But if you don't have any other place to put it, that's fine. A basement that you can see and get to is a good place. How is this constructed on the rebuild? The rebuild has a piece of solar board. This is 1/2 inch sheathing. Why? Because that's just what I had in the garage when I rebuilt it, and it's foil covered because I don't want it to go through there. And because it's sheathing, it can handle a little bit of moisture and not come apart. The sides and the pan are track for studs for metal construction. Okay, type 4 construction type, depending on what building code you have. Non-combustible construction, metal stud. It's the track at the bottom and the top. Now the first one I had is structural. The reason why? Because I had it in the garage from 2 previous projects that I had used it for. So I made a pan on the bottom to catch it, and I turned up the size, little sheet metal work. Then I noticed that I still was a little bit on the thin side. So I got another piece of track, another 10-foot piece of track, and I brought out and made this lip that we see the pipes coming through. It gets a little bit more coverage for all of this up here, and I put some sides on there for splashing. If something decides to start leaking and spraying, I get a little bit more protection here. I also painted the back wall with a better quality paint to allow for more wiping down. It's actually a semi-gloss instead of the flat stuff of contractor grade that we built a house with. But this catches our water. It's also hung on one point up top on a keyhole, and then one point down here, which is built to slide so I can get a good level and make sure my drains work. Other than that, they're just 2 household filters mounted to a backplane. The standard RO housing with its clips mounted to the back plane. I did use furniture nuts on the back of the board, and they are recessed in there so I don't scratch up the walls. I would adjust for vertical. That one time when I would adjust for vertical. Okay, so these things have furniture nuts on the back side. They're bolted through. Everything's trimmed off. The permeate pump is mounted the same way. It has a clip just like these guys have a clip. It comes with a clip. The shelf already pre-existed from the good old days 16 years ago when I built this. I did add a little bit of a pan out of the scrap that's left over because it actually hangs out a little bit over this one. And all of this hangs over a circular or round drain pan. Now, when I built the house, I wanted a rectangular pan just in this area that would handle both this water heater, which actually this is replacement water, but the water heater and the system. And the guy didn't give it to me. So when I rebuilt all this, I took all this out and I tried to get a rectangular pan. For $127, I could get a rectangular pan that was 3 inches too big. I couldn't fit it in between the air conditioner you see me pointing at right here, its drain line, its overflow safety pan, comes into this space, and then off of this wall, behind this right wall behind me, I have the same problem. I have a little nipple that comes out for the drain for these 2 pans. Couldn't fit it in there. Now, I could possibly go with a custom made pan, but hey, $130 for a rectangular pan, I wasn't able to do that. So I made sure that this is caught, and it has a drain. I'll show you little pictures, a little half-inch guest fitting with a 1/2-inch conduit nut on top. I put a hose washer underneath it so that I'm going up against the pan, screw that down nice and tight, and then came back and flattened it off so that I didn't have to have 4 quarts of water in the pan in order to run down the drain. Same thing up here. Show you a little picture of it so you can see it. These guys coming through the front, these are just pass-throughs so that I didn't want it just flopping out here, rubbing back and forth. This is a hem-folded front edge. These are hem-folded on the side. This edge is hem-folded. The top is hem-folded. So I have sharp edge protection by use of that hem-fold. And these guys just pass through. This is a 1/2-inch CPVC connector, again with a hose washer and a conduit nut on top. I have 2 little holes here which are just grommeted to keep from abrading a leak into that poly line. So that's how it's put together. Oh, in here I use Guest fittings, Watts fittings, Shark Bites, whatever brand you want to use. I think they're all Guest, but I use these, and I also use the little clips because it helps train the plastic. When you first turn these corners, the tubing doesn't like to stay in there, and some of these fittings are 16 years old, and so the washers are getting a little bit on the hard side. And by using the Guest clips or the collet clamps, whatever you might want to call it, that go in here, they keep this from accidentally popping off, but it actually helps hold that tubing going into that connector, that little quick connect, a little straighter and less likely to make a leak. Now these in various places are tied down with 1-hole straps of 1/4, 3/8, 1/2-inch, and 3/4, depending on how many tubes that I have. It's just something to hold them into place so that they're not, I can't think of something good that would be politically correct. I'm thinking in terms of a medical experiment. Frankenstein, like Frankenstein with the tubes going everywhere, wires and tubes. So I wanted it to be a little bit neat and organized. Also, I color-coded them so that you could see the circuitry, how it goes. Maybe it'll help you understand a little bit better. Now we need to talk about what I did right and what I did wrong so that you can learn from my mistakes. Now when I built this, I got some things right and some things not quite so right. First of all, I told you I needed a rectangular drain pan to get better coverage, and I didn't have it, and the contractor left me 2 round ones. I figured out what it must be. Not a standard size would fit in there, and these little round pans are cheap. The rectangular pan was expensive, so I got 2 cheap pans, and I have, of course, a family coming in to the house, and they're going to fuss. They need the water, don't like the way it tastes, get this going. So I was in a little bit of a rush, but it started out with a big whole house filter, and the idea with the big whole house filter was that I could fill it full of a bedding stone that we'd use in a typical carbon filter, taste and odor filter for a bedding rock, put that around that giant carbon filter, and basically have some remineralization in there using that big filter. The downside with it is those gaskets swell and they leak and they spill and they have to be changed. But the idea was I wasn't going to have to change it very often, much like this membrane that will go for a couple years if you don't plug it up. The idea was the second filter would be this large capacity that's capable of going, 30 gallons a day, every day for 6 months, rated before they tell you to change it. And that'd get a lot of years out of it. Okay, it was a problem. It didn't have adequate spill protection, and for changing wasn't so bad. I got a mop, I can clean it up, shop vac it or whatever. But when it had a surprise, it was a problem, not adequate drainage. The other issue was I started out with the simple understanding of how the RO membrane is rated and how it works, that it can only make so much and it tapers off as it builds up pressure, and you lose that pressure differential and you have very little storage. So my initial idea was to use that Wellmate 6, because I think it's a 20 gallon, you can look it up, it's a Wellmate brand, WM-6, but at the pressure ranges I had hoped to run it, I'd get about 6 gallons drawdown, and I figured if I just spent all night and in the wee hours of the morning making water and pumping it into that Wellmate tank, if everybody was nice and was doing what they should, we would never run out of water. However, I had 2 kids and a wife, and we would run out of water. So that didn't work. So I had to look at some way kind of improving that. Plus, I had complaints that it didn't deliver at enough rate, and somebody had to wait while the coffee pot filled up. And so maybe you got someone like that in your life. Maybe you're just the impatient one, but I had to work at that. So I think the first thing I did was put a permeate pump on this. Now this pump is an ERP 1000, an Aquatech. It is 16 years old and still clicking. It's still working beautifully, flawlessly. Now it was working when I had it put in the original system, and it only started leaking after I tore everything down and I disturbed the little O-rings in there. Now I replaced the O-rings, and we're going to find out how many more years this thing will go. But it's still going, doing well. And I have to tell you, at 16 years, this was manufactured in 04, and it wasn't leaking until I pulled the tubings out and reworked this thing. But I had a GE manifold RO system that came with that little tank, and that little tank just went in the garage, was not used, and I used the big tank to fill it, and that worked to a degree. After I put a permeate pump in there to pull up this extra pressure to get the delivery we wanted. The RO system mounted directly to the wall, behind the tank, behind the Wellmate, mostly over the pan. And that worked good until that plastic in that GE filter, that manifold, started blowing water against the wall, and that was a mess. So I went to a discrete mode, discrete filters, discrete membrane housing. It's just not on a rack, but all of it was on the wall. And that worked pretty good. Still was looking for a little bit more water, so I ended up putting a pressure pump in here. And of course, typical square D pressure switch on one side, the pump. And then that way I used that little white jug about this big that came with the GE. It's actually the high pressure tank. And so we learned to go that way with it. And it stayed that way for many years. It was kind of ugly, but for 60 years it delivered water to the house, and a good time was had by all. But occasionally we would see a little bit of water problems associated when you change a filter or something goes to leak. Remember what I told you, if it has water or wheels, it's going to give you trouble. You can count on it. It's going to cost you money and it's going to give you trouble. So this is the rebuilt, slower, put together model. And I have one other thing that I'll show you that's not on here now that was on the original model. So what is that one thing that I didn't put back from the original? It's this thing. And you might say, what in the world is that thing? And that would be a good question to ask. Because it's got a thing with arrow at the bottom. It's got one at the side. It's got this thing that says fill. Well, what a lot of people don't realize is, maybe they don't stop to think about this, but see, my house was plumbed for the RO, was plumbed off of standard CPVC piping, and piping such as that have an issue with it. It's not a big one, but what does RO water have in it, or not have in it, I should say, other than minerals? Well, it doesn't have any chlorine. It's got nothing to sanitize it. So the pipe that you normally will find at a plumbing supply house or a big box store, the pipe ends are open, they're full of dust and dirt and mold and mildew spores are in there. Could have had a cockroach run through there as a marathon. You never know what's in it. Could have been the back of the fittings, have been maybe handled 4 or 5 times, dumped in a box, and they're dirty. I mean, maybe they're not, necessarily life-ending dirty, but they've got some germs in them. And when you put city water through it with chlorine is in fact our friend. I know I got some people that think that the devil put it in there to wipe out the human race, but it's there for a reason. And when you have a pipe that is what we call clean, but not necessarily sanitary, when you run the city water through there, that's enough to keep that stuff down. RO system, when I first put in, didn't have any of that. And the water going through it wasn't going to be chlorinated because it came off that well. And I told you I had a big, tall computerized filter to take all the chlorine out. So what this little mollygog of plumbing parts are, actually there's quite a bit of dollars worth of plumbing parts here. But this is a reservoir. And it had a couple of little guest valves on it, so I could just bypass the RO system in its entirety and pump water in and then put the material in there so the water would put it. So what I do is put a little bleach water in this tank, close off the top, so it's closed, it's actually open here, fill it in, close it off, and then run water in the top, and it would push that chlorinated water, that bleach water, in through the system. Then I would run to each of the faucets, each of the lavatories, run water, test, run water, test. Mostly I'd sniff, see if I could smell a little chlorine, then I'd stop and check with a chlorine test. And if I had chlorine, I'd turn that one off and go to the next one, and the next one, and the next one, until I know each one of my devices, including the refrigerator, had some chlorinated water in it. Then I let them sit for a couple hours to sanitize and kill whatever was in the pipe at that point. Then we flushed it with water without that chlorine in it, and that's how we sanitized the pipes. So anyway, hope that's useful to you. There's one more video, a little short, tiny one that I'll do after this. I'm not going to tell you what's in it. You got to watch and see. Subscribe to my channel. If we ever monetize, you're going to have seen some commercials before we got here. This stuff costs money and lots of time to do. So if it's useful to you, just don't hate me because there's a commercial or two that you have to sit through depending on how long this video is. I think it's got a lot of good information to it, including some confessions of what I did wrong, what I learned, my learning curve, and how I've got it now. It'll give you some ideas. Surely, yes, if you're running out in a country somewhere and you don't have chlorinated water, you may have some choices. If you have clean water, but you just want to make sure that your drinking water, your straight up drinking water has been sanitize, you don't want to use chlorine, you can use UV. They make rack systems or manifold systems like that. You can do what like I started with, a manifold system to begin with and a large tank for capacity. You understand that this increases my delivery pressure and also controls my water wastage, as well as by as much as maybe 80%. Okay, depends. That's a number the company has given out, up to 80% reduction in wastewater, and of course the pressure pump just to kind of bolster regeneration. How quickly does it regenerate? Well, I've never really timed it, but since I got in this configuration, I've never run out of water either. So here's what it does. The house is set at 30 to 50 roughly, or 45 to 50, right in that range. It depends on that pressure switch. The inlet water from the city is about 50, 60 psi depending on the time of day. This guy will boost it to 90. It has been previously set at 100. I've made it at 90. So I've got about 40 to 50 psi differential on this membrane. And if it's a 75 gallon per minute membrane, you're going to have what, 37.5? At best, 37.5 gallons per day being produced. I don't use that much. That's plenty. But you could change out, put a bigger a harder membrane in there. You put a softer one in there, like a 50 gallon. If you don't, it's just going to change. The difference in that is going to have an effect of how much water you waste. This guy makes it where I don't need a tank shut off. It just comes up and it regenerates. If I don't use enough down to kick that pressure switch on, it'll regenerate just off the permeate pump running. So it's a good system. I think it works pretty well. Get good ice off of it. And anyway, hope it helps. Click, like, subscribe to anywhere you see me so you can keep up with this kind of stuff. And don't hate me if you see an advertisement in there, because I'm going to tell you, those little guest fittings are $5 to $10 a piece. So there's some money tied up in that right there. Start with a simple system and then put a big tank for the storage capacity. If you need it, add a pump or two. So anyway, that's it. Thanks for stopping by.